Okay, everyone. This is Pradeep Kumar K, Future Advancement in Enhancing Image Resolution with ESRGAN. So actually we have totally 6 authors over here, where all 4 of us belong to the Anand Sagar University, and one author Salma Itagi is from Sai Vidya Institute of Technology, and one more author Monica Agarwal is from PS University, Bangalore. CSE and ML department as well as core CSE department. We are working on this particular image processing and GAN GAN algorithm from the beginning. So in order to go with our presentations, this is the initial slide, what it has been prepared. We will be covering with a few of the contents which are mentioned over here, where I will be highlighting the 2 things where a proposed approach for ESRGAN, the 2 components which are available for ESRGAN, and what was the experimental setup we have used, and what kind of result analysis we are going to have. So on these highlighted topics, I'll be briefing it out in my particular paper. So basically, ESRGAN is nothing but a kind of enhanced super resolution generative adversarial network, which is one of the super resolution technique. So that is a very known technology nowadays, which will be having the more advanced technologies or super resolution techniques in order to convert the image, the low quality image, into high quality image. So in order to do this kind of work, so we have a complex mathematical algorithms to reconstruct and refine the details of that image. So in order to increase the resolution, in order to increase the visibility of that particular image, this ESRGAN will undergo a complex mathematical analysis. So ESRGAN introduces several innovations to the traditional GAN framework. So we have GAN, which is nothing but generative adversarial network. That algorithm will also help for image quality improvement. Along with that, we have several other innovations which are available with respect to ESRGAN. So the ESRGAN produces high resolution images that not only exhibit improved pixel level accuracy but also preserve important visual structures and textures. This ESRGAN basically having applications in terms of medical imaging, surveillance systems, digital content creations, and much more. So this ESRGAN finds to be a very important role while using the image processing techniques. So the main motivation of our work is increasing demand for high resolution images. Because of having increasing demand for high resolution images, we started to work on this ESRGAN area. Limitations of traditional super resolution techniques. We have, as it has been analyzed, that GAN is one of the traditional technique and ESRGAN is one of the advanced technique. So we do find some of the limitations in traditional super resolution technique. So we underwent with the ESRGAN. Advancement in deep learning and generative adversarial network made us to choose the area called as ESRGAN, potential applications and impact. So as well as improving user experience and perceptions. These are the motivations which made us to work on this ESRGAN field. The objective of our research work is to investigate the principle and architecture of ESRGAN, evaluate the performance of ESRGAN in enhancing image resolution, explore the potential applications of ESRGAN, and to highlight the limitations and challenges of ESRGAN. So these are the few objectives what we underwent as a research work for our paper. So the related work, that is the review papers, what we have considered while executing this particular framework is like this. Though we have identified around 15 to 20 or more than 20 paper also, but here as a time being or a time construct, a time stamped. So we have been using these 3 techniques, these 3 reviews for our literature review. So 3D brain MRI reconstruction using 2D super resolution. So this was the core paper. Actually, we have used it for our particular project. This has been worked on the 3-dimensional convolution neural network, which was being used. Super resolution methods for MRI images in 3 dimensionals have been investigated. So it has been actually started with a 2-dimensional work, and then later they invented with a 3-dimensional, and basically they have worked on the brain MRI reconstruction signals. So they wanted to reconstruct the brain MRI signals with the help of 2D resolution images, adding up with a 3D with the help of ESRGAN. So this made us to choose this particular area in order to go with the image processing technique, in order to go with the image processing concepts. The second paper what we referred is billet number recognition using ESRGAN with the help of improved YOLO V5. So this paper had made us to analyze with the number plate identification. So usually nowadays, because of AI cameras being installed in the traffic signals and to identify the malfunctioning happening with traffic rules and all. So with respect to this one, as the normal cameras and all used to take the images with a very blur. So by using this ESRGAN, we have been trying to improve those images, those quality of those images. So that concept we came to know by studying the second paper. And the third paper, what we have referred and what we made it as one of the good paper for our reference is having a deep CNN real ESRGAN for lung disease prediction. So actually we all 5 to 6 authors who are there were working on ML in health area. So we do have more preference towards medical sector. So the third paper also we took towards applying the ESRGAN for the lung disease prediction. So these are the 3 papers which made us to work more on this area, that is ESRGAN. So based on this reviews, the proposed algorithms, what we had it has been highlighted in this slide, which is supposed to be called as an architecture of ESRGAN. So first and foremost, we will be inputting a low resolution images, that is having a blur image or maybe a foggy image, so on and all. We will be taking that input and we will be using the feature extraction as a first step. In that feature extractions, we will be considering small blocks, we will be considering summations, we will be considering the beta transmissions and all. We will be using it in future extractions, and then slowly we are making that low resolution input in order to be using with respect to convolution 2D network. So we will be converting with respect to convolution 2D network. So then the convolution 2D network or the convolution 2D matrix, what we will be getting from the input images, slowly we are upscaling it up. So in that upscaling work, we will be considering convolution 2D ReLU networks or ReLU algorithms and all. It will be used in order to upscale each and every pixels or each and every matrix available in that image. Then later on, fine-tuning with image reconstructions and all we will be processing with respect to image reconstructions. And finally, we are going to concentrate with the high resolution output of a same input image what we are going to use, right? This is a simple architecture what we have proposed for our ESRGAN. So majorly in order to do this particular work, like considering the low resolution images and taking out and bringing up with an high resolution images, the ESRGAN usually works with these major 2 components. One is called as generator network and another is called as discriminator network. So in generator network, actually we are using it as a deep convolution neural network architecture, which is commonly used for generator network in ESRGAN. It composed means this GN, I can call it as GN. It can composed of several convolution layers which are governed by activation functions such as ReLU, which improves the spatial resolution and assists at capturing visual details. So it also skips the connection, and residual blocks are frequently utilized to improve the information flow and help the network efficiently to learn residual mappings. So this the generator network will be acting as one of the component in ESRGAN. Whereas we have another component which is also called as discriminator network. In discriminator network, it is very crucial as compared with the adversarial process. Differentiate among the high resolution images generated by the systems with a ground true high resolution images. So this actually will match with the final output and with a pre-limited output, like like what I can say, the before output, the partial output what we are going to get, it will keep on checking whether that the partial input is a high resolution image or still it can go for higher one. So this is what discriminator network will do. So here also we will be having a convolutional network which is commonly used as a discriminator network, which undergoes a training to classify the images into real or fake categories. Along with highlighting the images or along with improvising the quality of the images, this discriminator network will also deal with either real or fake categories. So these are the 2 components which we have used in the work, which we have used in our particular work. So next, moving on to the further, like this is the experimental setup what we have. So we will collected the data set. There's a data set selections, and then we went with a data processing. Next, with respect to the architectural, that is network architecture, we have been used, and the training procedures. We have taken much more sample images before going with the actual testing process, because we know each ESRGAN will be having a separate training data set and it will be having a separate testing data set. So we have a huge amount of data under training, and we have a huge amount of data under testing data set. So then based on the available training and then testing, so we have actually evaluated the metrics. We have checked out with the baseline models. We have used ESRGAN. We have used a much more convolutional network, as it's been already informed. CNN, ReLU algorithms will be acting as a baseline models. Then we went with a qualitative evaluation. So then based on that, statistical analysis and experimental replications we have been done. So this is the entire experimental setups what we underwent in each and every step of our execution. So this acting as a key component of using ESRGAN also. Right? So when we started to train our particular model, actually we have taken 2 random images. One, you can see the first images, what you can see it here is what kind of blur image, when we put it into my particular algorithm, somehow the image resolution, even somehow the space, means some of the like what I can say, the size of that file, even the image resolution of that file, everything it has got increased. So in the first image where we can able to see the image which is in blur of JPG image, the more fascinating image when it comes to the approach of ESRGAN. Similarly, the another input, the random input, what we have taken is from the space satellite, so which is of airport. So we have taken that airport image, means the airport image from the satellite, and we have been processed with respect to our ESRGAN. And at least somehow we have come to have some extra resolution or some extra good quality images when we process with a ESRGAN. So these are the two sample outputs what have been showing with you people. Meanwhile, along with that sample input, we have been trained the model for analysis of each and every inputs. So we have the execution file also with you people, so that I will be explaining you when I be presenting it in front of you people in an online mode. So these are the result analysis. And when I talk about limitations, so we have computational complexities, we have training data set requirement. As I said, huge amount of training data set is required. So then providing the training data set itself is one of the limitations, or else it is one of the challenging one. So overfitting and generalization is what one of the very much required one. RT graph generation, subjectivity in evaluation, scale limitations, and then real-time application. These are the few limitations and challenges what we observed during our natural process of the execution. Next, when I come to the conclusion, so basically I would like to conclude that ESRGAN builds upon the traditional GAN architecture. It contains all the traditional GAN models. Along with that, some enhanced super resolution GAN algorithm also it has got. So in order to have a improved version which involves such as perceptual losses, deep network architecture with skip connections and residual blocks, and advanced training strategies to enhance the performance of super resolution tasks. The work what we have undertook, it has got various aspects of ESRGAN, including its architecture, working principle, experimental setup, data set selections, pre-processing techniques, training process, evaluation metrics, limitations, and strategies for improving its performance. We have undergone with each and every stages of execution. We have checked out with the ESRGAN, which offers great potential for a various range of applications, particularly enhancing image and video quality, improving medical imaging, satellite imaging, surveillance systems, and much more. So this is the usual applications what we have run our ESRGAN. And by understanding the strength of weakness and then strength of ESRGAN, we can have the limitations where the researchers can work on those limitations, and then challenges. The researchers and practitioners can take up those work in order to more improvise with respect to the ESRGAN. So finally, I would like to conclude that we have executed this ESRGAN approach in order to enhance a few resolution wise or a few increased pixel wise for the given low quality images. So these are the in order to put forward, I would like to thank my university, the Anand Sagar University, Haroldi campus, Ramnagar, Karnataka, for providing us the opportunity to undergo this particular research work and bring it into a kind of a paper and the publication work. And I also thank, on behalf of my co-authors, I also thank Sai Vidya Institute of Technology, Rajan Kunta, Bangalore, and PS University, EC Campus, Bangalore, Kannada. These are the three universities which we have collaborated and we have started the work. And each and every author has got their own role in order to be making this project work to be a trusted one and to be a workful one. So, and putting up with respect to the paper. So these are the references what we have used for our execution of ESRGAN. So finally, I would like to thank the organizers of this Win 6.0 conference, right? So Kolkata, the team, the IEEE Kolkata team. So I would like to thank wholeheartedly for providing us the opportunity in order to be a part of it and to accept our paper and to provide us the opportunity to go for online presentation. Thank you one and all. If there is any queries, then please drop your queries in the chat box section so that I can be available to answer for your particular queries. Thank you one and all. Thank you once again.